Guided example, chapter 4.2, applications of systems of inequalities. Guided example number 1, solve the systems of first inequality x plus y greater than or equal to 6. Second inequality 2x minus y greater than or equal to 0. So in this case, we're going to make the graph one at a time. The first one, x plus y greater than or equal to 6. I'm going to find the graph by solving for the x and the y intercept. And you can see the format already ready there for you to calculate. So first of all, I'm going to put the 0 here for x and for y here 0. So the top one, we're looking for the y-intercept. For the first inequality, we're going to replace the x by 0. So 0 plus y is gonna greater than or equal to 6. So basically, it's gonna be y greater than or equal to 6. So I'm going to make the dot right away on the graph. Y is going to be greater than or equal to 6. So make the dot. So it's going to be 1, 2, 3, 4, 5, 6. It's about there. So y is going to be greater than or equal to 6. So bigger than, I make a little small arrow to the top. Means it's bigger. And then the second part is y is equal to 0. We're looking for the x-intercept. So we're going to substitute the y by 0 greater than or equal to 6. So obviously x is going to be greater than or equal to 6. We're going to put it here too. So x greater than or equal to 6. And remember, it has an equal sign. So at the number 6, it's going to be a solid dot. 1, 2, 3, 4, 5, 6. So 6 is going to be bigger than 6. First of all, we are going to connect, draw a line, and also it's going to be equal to, so we have a solid line. And right here, that's the line, and above, and you can see from the pictures. So next, we're going to the second inequality, and I'm going to solve for the y-intercept and then x-intercept. So I'm going to put down x here and the y here. So we're going to substitute the x by 0. So 0 minus y is going to be greater than or equal to 0. But you cannot have a negative y, so we're going to divide it by -1 on both sides. That will give me a y is going to be, make sure you switch the sign. Y is going to be less than or equal to 0. So I'm going to put it here. Y is less than or equal to 0. So it's a solid line, solid dot. And the second part is, since I know x and the y both are going to be 0, that means the second point right here, if I'm going to use y is equal to 0, I will not get a different dot other than the origin we had already. So in this case, we're going to pick a different point for the y value, and you can pick any number if you want to. So I think it will be easier. I will just pick the y is equal to 2. I'm going to write down here, it's a 2. Okay, so now you can pick 1, you can pick 2, you can pick 3, you can pick 4. Is up to you. Okay, so I'm going to pick y is equal to 2, and I substitute the y by 2. So I'm going to have 2x minus 2 greater than or equal to 0. You bring the 2 over. 2x is going to be greater than or equal to positive 2. After you divide by 2 on both sides, you should be able to get a point. X is going to be greater than or equal to 1. So this is the point. X is going to be 1, and the y is going to be 2. So the place the intercept is right here. I'm going to connect the dot. And the y is gonna be less and the x is gonna be bigger than the 1. So connect those two dots. And it's gonna be less and greater than the x equal to 1. So basically, I look at the arrow. This part shows to the right. This part shows to the right. Okay, so in this case, my final answer is gonna be in the entire region of this part. Satisfy both conditions. Okay, in this case, we did not define the x and the y must be greater than or equal to 0. So in this case, entire region can be my solution region, but that's the best solution right here. They intersect, and we're going to solve this part later on, but this is the entire solution region for this linear systems.